Okay, who's ready to get started? All right. So nice to see so many familiar faces. Ran into a lot of people today. So while people are filing in, I'll start with a story. I have a 7-year-old son. And a couple of months ago, he was going back to school. And I figured I'll take a week off and I'll spend it with him. So I said, okay, what do you want to do? He said, I have this long list of things planned. I said, great. What's your list of things? And he lists all of the things that he wants to do, including I want to go to Australia, I want to go to Vegas. 7 years old. I'm like, you know, we only have 1 week. This stuff is not going to fit, so why don't you choose the stuff that you really want to do? He said, no, I want to do it all. Like, okay, I'm going to be 100% dedicated to this project. I'm going to spend every day with you. The 2 weekends and the 5 days in between, 9 days. But this stuff is not going to fit. He said, no, I want it all. I'm like, it's in somewhere. I have an idea. Why don't you put every single one of your ideas on a post-it note, and then we'll arrange it on a calendar. He's like, great. So we put it on the post-it notes. He started working on the calendar. Once in a while, he returned to me and said, how long does it take to get from Australia to Vegas? And I'm like, oh my God, I'm in trouble. But then at the end, he ended up arranging it all perfectly, just took 5 minutes. Half of the stuff didn't fit. His top pick, Australia, didn't fit. We got San Diego Zoo instead. It's okay. But he was happy, right? He participated in the project. So agile planning works, even in family situations. So I just told you a little bit about myself, and I want to hear about you. So by show of hands, how many of you launch to production at least once a year? That should be everybody. Okay. At least once a quarter. Okay, almost everybody. Once a month. That's pretty good. Once a week. Okay. Some drop off. Once a day. Very nice. More than once a day. Great. This is excellent. Okay. Continuous delivery. Oh, I forgot to introduce myself. My name is Stas. I'm an architect with Yahoo. I work for advertising and data platforms. And I'll talk a little bit about our system later on. Continuous delivery is defined as commit to production without human intervention. Continuous delivery increases velocity and improves quality. Continuous delivery is table stakes today. If you are not doing it, chances are your direct competitors are doing this and they will have you for lunch. About 2.5 years ago, my manager approached me and said, CTO thinks this continuous integration thing is kind of important. Can you look into that? I said, sure. So I went to one of our flagship products and I said, I want to understand exactly what happens between your commit and production. How do you build, how do you release, how do you test? So I sat down with them. What do you guys do when you commit code, after you commit? Oh, beer. Sounds great. Okay. I take it you don't email your manager saying that, hey, I just committed. Well, that's what this team was doing. So imagine this senior developer. I sat with a senior developer, Steve. And it's Tuesday, and Steve just worked 2 intense days, and he's finally done with his functionality. He checks it in. He sends an email to his boss, Linda. Like, Linda, I just checked in. And she responds immediately, thank you so much. You worked so hard. I'll just wait for the rest of the team to check in, and then we're ready for the build. And the rest of the team is something like 70 developers. And the code base is hundreds of thousands of lines of code. So Wednesday goes by, Thursday, and Thursday she sends out an email to the team. Okay, make sure that all of your check-ins are in by noon tomorrow so that we can have a clean build at the end of the week. And by noon tomorrow, most of the check-ins are in. People are more or less disciplined. Of course, a couple of people are late, and then there's a late-breaking bugs and late-breaking functionality. So by 3 o'clock or so, maybe by 4, they're done checking in. So Linda sends out this congratulatory email to the group. Thank you so much. You worked so hard this week. you deserve a weekend. Please rest on the weekend. And then she sends an email to Bob, the build guy. Like, Bob, can you build? We're ready. And Bob, is doing something, whatever it is he's doing. Turns around, sees the email, subversion checkout, waiting. Gmake. What do you think happened? It broke. Of course it broke. It had no chance in the world of ever succeeding. So by 4:15 or 4:30 on a Friday night, he replies to the team saying, hey, your build is broken. Now, this is not their first rodeo. They know what to do, right? So they branch immediately, and they try to stabilize it. And they try to stabilize it until probably about Wednesday of next week, so that they can spend Thursday and Friday trying to launch it to test environment. So that on Monday, QA shows up and tests it. And QA shows up on Monday, and what do you think happens? Nothing works, of course. This team launched to production 3 times a year. I don't know how they could do it, actually. Because they would all start coding on a flag day, and they would code intensely for 6 weeks. And they would try to pass tests and send the stuff to QA in parallel, because you don't have enough time. And then they would spend 8 weeks in heavy testing. And at the end of 8 weeks, you gotta ship. You gotta ship no matter what. So QA signs off with a long list of exceptions. And then they spend 4 weeks launching to production, carefully orchestrated production launches to thousands of servers. And then production incidents start. And they would spend a couple of months dealing with production incidents. The same team today. They launch regularly every week. They go from commit to certification without any human involvement in about 6 hours, and they will work on speeding it up. They're in position to launch every day. So if there is a break fix or some security issue in production, they can get it done, they can get it released the same day. But normally they don't have to, because they don't have production incidents, at least not of the gravity that requires them to push that day. And we just stress tested the system last week. We found one of the open source libraries we use, it was found to have a security issue, and we had to launch that same day, and they did it. Continuous delivery has become part of the culture. Nowadays, when a new product is delivered, we expect them to launch to production multiple times a day. We just recently launched a brand new advertising product several months ago. When they went to production, initially they were launching every 30 minutes. And the only reason they still had a human pressing that button every 30 minutes is because of our Sarbanes-Oxley compliance rules. If we didn't have to deal with that, we would just go commit to production without any humans. In fact, for some internal services, that's what we do. My team developed a couple of services recently. When a line of code gets committed, it's in production in 30 minutes. No humans involved. We went from continuous debacle to continuous delivery. And we learned a lot in the process. I'm here to share those lessons. First lesson, don't do it. If your manager approaches you and says, hey, can you take a look at this? Can you get continuous delivery implemented in our organization? My advice to you, don't do it. People will laugh at you. People will think that you're crazy. People will get angry with you. They will ignore you. They will hide from you. They will roll their eyes. You will get frustrated. You will get burned out. So don't do it. Let some other fool do it. I actually expected you all to leave at this point, but I see we have a lot of idealists in the audience. So from one fool to another, here it comes. Before we get into deep lessons, I want to talk a little bit about our system. It's important to understand the system that we deal with, because a lot of the decisions that we took, a lot of the approaches that we took are based on the nature of our system. If our setup was different, the decisions and approaches would be different. So I work for advertising and data platforms. And as the name implies, We serve a lot of ads, and we process a lot of data. We process more than 100 billion unique events per day. And that's insanely huge data. We process all of Yahoo's data. These products, they deal with billions of dollars every year. It's a very heterogeneous system of thousands of servers, hundreds of unique software components. We have homegrown technology, we have technology that came through acquisitions, we have third-party technology, we have the current technical stack, legacy technical stack, experimental technical stack. We have all kinds of languages and technologies in the house. We have Java, C++, Perl, PHP, Groovy, Ruby, Clojure, Scala, MySQL, Oracle, Hadoop, Pig, MapReduce. I should stop here. We have it all. And all of it has to come together and work somehow. And of course, there's hundreds of developers working on this, and they all work on different teams, and they all have different priorities and different schedulers. So I end up working with a lot of teams. And the first thing I tell them when I meet them for the first time is CD is simple. You already know how to push your bits to production. You already know how to build and release. You know how to deploy. You know how to certify. You just need to automate it all. It's that simple. Sure, you'll learn a lot of interesting things in the process, but really, it's not mysterious in any way. So if you came here to learn about our magic technology or our special tools, I think you will be disappointed. It is actually simple. And the first thing they tell me is, but we are unique. Every single team told me this. And I say, yes, of course. You are unique, and he's unique, and she's unique, and I'm unique. That's what makes us great. You still have to do continuous delivery. I haven't met a team that was not able to do it. If you are to take one lesson out of this talk, it's this. It is the mindset. It's not the tools, it's not the technology, it is the mindset. You want to get to a point where continuous delivery is part of the culture. And until you're there, you are attempting a cultural change. And that is extremely hard to pull off. So how do you make it happen? I've tried it all. We've tried it all. We went by the book. We celebrated quick wins. We gave t-shirts out, stickers, hats, you name it. It all had very limited impact. Really, the only thing that I've seen work is mandate. When a manager or a VP mandates that this has to happen, it happens. Not immediately, but it happens. That first team that I mentioned at the beginning of my talk, that was launching 3 times a year. At some point, their manager was so frustrated, he was so desperate, he said, I'll try anything. Continuous delivery, sure, sounds good, let's try it. And he made it a mandate. He overrode all of his managers. He overrode all of his senior developers. He doesn't know it. They came to me to complain. They said, you're setting us up for a failure. We are going to fail. We're not going to deliver our features. We will be late. We will waste all this time. Why? Why are you doing this to us? They didn't have an option to opt out, so they had to do it. And it took about 3 months until they realized that this is actually a good thing. And they never looked back. It took them about 2 years to convert completely, and only because they couldn't stop the production line and retool. But once they tasted it, they couldn't go back. Initially, we got to 2 very big successes very quickly. And I was thinking logically, people will see it. And they will adopt continuous delivery. It's a no-brainer. But I was thinking logically. When you're dealing with mindset, that's not how people think. So even though we had those 2 huge successes initially, people still would not adopt continuous delivery. And it took a mandate from a senior vice president for the division to make it happen. Once he said, we're doing it, and you have no option to opt out, that's when it happened. Even with the mandate, it takes time. I think the reason for this is it takes time for people to absorb the information, experience it, and internalize it. We have a sister team in India. They started about 12 months after we did in the United States. So I went to India to kick it off, and I noticed that I'm having the same conversations with these guys as I was having in the US 12 months prior. And I thought, interesting. Well, they'll catch up, right? We have processes, we have tools, we've figured a lot of stuff out in the past 12 months. They'll catch up. And then, ever since then, I felt like I was in a time machine. I'm having the same conversations as I was having 12 months prior. And that's when it hit me, that it just takes time. Mindset change just takes time. So actually, I told their VP, I said, hey, I think you guys will forever stay behind us, 12 months. He said, no, impossible. You have the tools, you have the processes, you have the templates. We now know what to do. And they did catch up by a little bit. They have a lot of focus. They have had a lot of energy. They used our processes, our tools. But they're still, even today, they're about 9 months behind us. So your job, if you're that fool who signed up for this, your job is to keep that foot on the pedal and never let up. You have to keep on applying pressure. If it takes a year, if it takes 2 years, you have to be persistent. Even with mandate, people are still afraid of the change. You are dealing with fear, uncertainty, and doubt. For many people, adopting continuous delivery is a leap of faith. And it's scary. And they will find thousands of reasons to tell you why it will not work. The best weapon I found for this is hard facts. You cannot argue with facts. Just last week, a team came to me and they said, we're building this brand new product. It's so complex. Just look at our setup. Just look at our algorithms. It's so complex. We have to do manual testing. It's impossible not to do manual testing. Really, the only way I could solve this problem for them is to point them to an ad server that kind of looks like their product and say, hey, this ad server serves 10 billion ads per day. And it processes $1 billion every year. And you're telling me you, with your little product, cannot do this? That's an argument that they couldn't win. It's important to understand that continuous delivery takes time. It's not cheap, and it's not fast. It will take resources. The best advice I have is stop the production line, retool, and then start delivering. Unfortunately, we couldn't do it. We had to do feature development in parallel with continuous delivery adoption, and it took us a long time to convert. But if you have that option, definitely stop and retool. Because it's so expensive, it's best to start with continuous delivery upfront. Nowadays, we expect new teams to develop their continuous delivery pipeline before they check in a line of code. We want them to take a Hello World program and take it to production with a pipeline before they start adding functionality. This works best. Just a couple of months ago, we had a product that was just about being started. And the head of engineering talked to me. He said, I believe in continuous delivery. I experienced it on my previous product, but we cannot afford it. We cannot afford to do it. I kind of figured that he was coming from the experience of converting legacy, and his previous experience was it took a year to do continuous delivery. And I told him, hey, you know, if you start with it, it will take you only 2 days. And I was able to convince him. They implemented it, and today they launch multiple times a day. They're so happy. Every time I run into him, he tells me, he says, you saved our butt. So start with CD if you can. Because continuous delivery is so expensive, because it takes so many resources, because it takes time, because it's a mindset change, you really need executive support. I would not even start on this if I didn't have executive support. It's a strategic decision for your division or for your company. I think I was very fortunate to have worked with very good executives that supported me all along the way. But I think executives are smart. If you go to them with math, if you go to them with some quick wins, if you show them what your competitors are doing, they'll sign up. Problem is they don't know how to go about it. Well, that's your job. You're the fool who signed up for this thing. Ownership is the key. In our case, we eliminated QA department and we eliminated release engineering department. Today, developers, the team owns code from fingers to production. It is their responsibility. And that really worked. For years, we've had issues with engineers writing unit tests. We asked them nicely. We used carrots, we used sticks. Please write unit tests. If you don't write unit tests, something bad is going to happen. It just never happened. And if you think about it from the developer's perspective, why write unit tests? I'm just going to throw this code over the wall and an army of monkeys are going to go at it. That's the mindset, right? Well, guess what? Now you're responsible. And developers these are top-notch developers. They're not going to ship crap to production. They take pride in their work, right? They will find the best ways the most efficient ways to test this stuff. They will find ways to automate. And I was surprised so many times, pleasantly surprised so many times, about the innovative ways that our developers have found to automate testing. And that includes unit testing. Of course, we started seeing number of unit tests go up because that's the most efficient, it's the fastest way to test. We started seeing the same with functional testing and performance testing. So ownership is the key. To repeat, 3 big lessons. Mindset change, you must have executive support, and ownership is the key. Next, I want to talk about some of the tactics that we took. But before I talk about that, I want to share something with you, something personal. Yesterday, a developer mailed me their resume. And nowadays, it's very rare that somebody mails you their resume. Typically, you have to hunt for them. And he mailed me and said, I want to work for your organization because you believe in technical excellence and you practice technical excellence. That felt very good. Anyway, tactics. First thing that we had to do is we had to standardize on our domain model and terminology. Initially, we went to talk to all these teams and everybody used different language. We would spend 10 to 15 minutes working with them, normalizing our terminology. We needed one of those Star Trek translators things. So we took this step early on. We normalized the terminology. We came up with a standard domain model. What's a system? What's a subsystem? What's a component? What's a unit test? Right? We all had to speak the same language. That really worked. Surprisingly, I don't know why, it met resistance from some teams. Some teams were just so religious about their terminology, and we had to fight that, but I'm not sure why that happened. The next principle that we've been practicing is architecture first. If you have crappy architecture, you can't automate your way out of it. You have to fix your architecture problems first. That typically means decoupling. If your systems are coupled, if you cannot launch independently, if you cannot test independently, you probably have to re-architect. Also, we've seen several tech stacks being changed or updated because they were old legacy and people didn't want to automate, or it didn't make any sense to automate this old crappy stack, and people would upgrade first and then automate. And we supported that all along the way. In fact, continuous delivery mandate was used by many teams as a way to introduce architectural changes, long overdue architectural changes. The general approach to implementing continuous delivery is actually quite simple. You take the smallest unit of your product, whatever it is a library or a script, and you certify it in isolation. And as soon as it's certified, you build the next thing out of it. And you certify it in isolation, and the next thing. And eventually you have your entire launch unit assembled, built, and certified. And once you do that, you're ready to launch to production. Very simple. This was one of our mistakes. We went breadth first. We started talking to all these teams, and we wanted them to do all these changes in parallel. should have gone depth first. It took us about a year to realize that we need a fully working commit to production pipeline. And we did it. It actually was not that hard to do. But once we did it, we removed a lot of that fear, uncertainty, and doubt. We proved that the concept works. We proved that the techniques work. Tool set is there. Many people said, hey, we don't have the tools. Well, guess what? We do now. It also acted, it was a significant milestone, and it also acted as a template for a lot of people. Today, when I look at our pipelines from different products, many of them look like that original pipeline because people use it as a template and they enhanced it. You have to define a clear end state. Developers need to know when they're done. The simpler the end state, the better. In our case, it is very simple. Commit to production without human intervention. We only allow that one caveat for SOX compliance where an actual person has to click to go to production. In fact, our end state definition was used as a motto for us. Commit to production without human intervention. Commit to production without human intervention. We even had posters with this motto. Once you define a clear end state, you have to define the degrees of freedom. And the way I looked at it is, it's the flip coin of the ownership question. Flip side of the coin of the ownership question. If you own your product from fingers to production, then you get a lot of freedom to decide which tools to use, which processes to use. So really, we don't mandate a lot. The only mandate we have is no humans between commit and production. The rest is up to you. The technologies that you choose, the processes. We provide recommendations, we provide guidance, pros and cons for a lot of technological choices. But it is your decision to make. And 100% of the time, people make good decisions. Launch units clearly have to be defined. These are the things that you actually launch to production independently. Whether it's your systems that launch independently or subsystems or whatever it is you call it. You have to clearly identify your units. Each one of those units has to be launched independently, certified independently, and hence they need an independent continuous delivery pipeline. If you find that you cannot certify a launch unit independently, somehow it's tied to coupled to a different launch unit, that is probably an indication of an architectural coupling that you need to resolve. Now, important to understand that some functionality is supported by multiple launch units. In a system like ours, we could have 10 launch units supporting one feature flow. So what do you do in those cases? Well, the answer is simple. You test in production. Just like that International Man of Mystery says. And for that, you need flexible feature flags. People call them flippers, people call them different things. But we all know what feature flags are. They're the configurations that control whether your functionality is on or off. Flexible feature flags are just like that, except instead of being static configurations, they're dynamic. So they do it based on the state of the world. Whether it's the account that's logged in, or the IP address, or day of the week, or phase of the moon, whatever. So those feature flags they're really magical. They allow you to do a lot of things. They allow you to separate the notion of software release from software deployment. They allow you to do selective exposure of features to specific accounts so that you can do that testing in production, end-to-end testing in production. They allow you to have the absolutely latest code out in production and not to branch if that's something that you want to do. And the best thing about them, they're extremely cheap and easy to develop. But the return on investment is huge. I think they're a must. I don't think you can do continuous delivery without flexible feature flags. This occurred to me as an afterthought, actually. This was one of our early learnings, and I almost forgot to talk about it. It has become second nature. But configurations, tests, test data should be treated just like regular code. It should be in version control. This is my personal tactic. I only have so many hours in a day. I could spend them trying to convince people that don't want to be convinced, or I can spend these hours talking to people that want to succeed. And I prioritize the second kind of people. Similarly, you have to be opportunistic and grab those quick wins and find those early adopters. And sometimes people who are in most trouble are the most desperate, and they will give this snake oil a try. Our first two huge successes were teams that were desperate. They were in such a bad state. Quality was bad, constant production issues. They couldn't get stuff out of production fast enough. They tried continuous delivery and never looked back, became our biggest successes. Tools and infrastructure goes without saying. You need tools, you need infrastructure. This is where that first end-to-end example comes in handy. At that point, once you build that end-to-end example, you know that you have all the tools needed. One thing to note is you should probably expect an explosion in the number of builds. Very early on, we started seeing growth in the number of builds. We started seeing a couple hundred builds a day because people start automating everything with Jenkins builds. We thought it was great. Well, today we have more than 8,000 builds every day. We have 13,000 jobs defined on our Jenkins farm. And I want to put in a plug. Tomorrow we will be sharing some of those details at the Scalability Summit. I don't know why that is, but universally people agree with this. For some reason, junior engineers can't get it done. Senior engineers understand your code better. They understand the interfaces, the seams. Our best pipelines were set up by the most senior engineers in their respective teams. So put your senior engineers to good use. One of the learnings is that if you're converting a legacy system to continuous delivery, most of the time is going to go to converting manual tests. You will build your pipeline in days or weeks, and it will take months and quarters to convert manual tests into automatic tests. And that is a very thankless job. A lot of people do not appreciate the work that people do to convert manual tests to automatic tests. So please provide them words of encouragement. They're doing a very important thing. The good news is that you will see incremental improvements in quality as they're converting, as more and more tests get converted. This occurred to us much later, but this is interesting. Continuous delivery gives you agile options. Remember I talked about those teams that launch to production multiple times a day? They send new features to production every day. The 2-week or 1-week sprint boundaries seem so artificial to them. Many of those teams converted from Scrum to Kanban for software development. And if you think about it, in my mind, Scrum was almost created in the world where continuous delivery didn't exist. Because you need to finish on Friday so that QA can really test this Monday and Tuesday, and then you can launch it to production on Wednesday. But now that you launch new features to production every day, multiple times a day, those boundaries seem kind of artificial. So we had a bunch of teams that converted to Kanban for software development. They were very happy about it. My team did the same thing. If you're converting from waterfall to agile, I would still suggest going through Scrum because you get to develop those agile muscles. And you get to develop those agile muscles with Scrum. Kanban requires a lot more personal discipline, so I would do it next, if that's something that you want to do. But the great news is that with continuous delivery, you have options. Tools used. Lots of proprietary tools, unfortunately. From the open source world, I'd like to highlight a couple of tools. Jenkins, first and foremost. Thank you, Koske. Thank you to the community. Liquibase is another tool that we use a lot to manage our database changes. Cucumber, we use Cucumber for behavioral-driven development, and we use it just for straight-up functional testing. These are the questions that I often get when I work with teams. First one is, how do I do DB rollbacks? You don't. You can't. So just make sure your changes are backwards compatible. And if you make a mistake, roll forward. Next one is, how do I know that I've done enough testing? Use your head. And so I don't know where this one is coming from. This one is interesting. It goes like this. So with CD, I know that this product does what I expect it to do. How do I know that it doesn't do what I don't expect it to do? I don't know where that is coming from. Well, you don't. It's mathematically impossible to prove, whether you do manual testing or automated testing, so just move on with your life, stop asking stupid questions. This is an interesting pattern. It came up several times. In the most extreme example, we have 200 engineers committing constantly to a small number of Java files. And they all work on different teams. They're all on different schedules with different priorities. What do you do in that case? The instinctive reaction is to branch. Branch immediately so that you can control your own world. This is probably the only time where I have a strong recommendation for branching. And my recommendation is not to branch. You have to develop a continuous delivery pipeline. You have to launch at least as fast as your fastest team. So just launch multiple times a day. And don't branch, ever. It almost feels and seems counterintuitive, but I've seen it work on several occasions. And that's what really got this problem resolved. This question I get a lot. I only have so much time. Do I do it fast or do I do it right? And when I hear this, most of the time I hear disempowerment. It means that teams are not taking responsibility for their decisions. So my comeback is do something and take ownership. And I'm not here to answer this question. You have to answer it yourself. Measuring progress is tough. I know when continuous delivery is done because there are no humans between commit and production. But as long as there are humans, I cannot tell you if you're 50% done or 90% done. I haven't found a way. I can see your velocity increase. I can see your quality improve. But I cannot tell you that you're 90% done or 80% done. I haven't found a way. Metrics. What are the good metrics? Our teams have tried a lot of metrics. I think popular ones are time to resolve a broken build, percentage of broken builds, code coverage, cyclomatic code complexity. They're all good metrics. In my mind, they just tell you part of the story. I haven't found a metric or a set of metrics that give you the full story. So if you have any suggestions, I'm all ears. So in closing, I wanted to share a picture of success. What does success look like? If I look at some of our successful teams, those are the ones that launch multiple times a day, this is what I see. I see multiple launches a day. I see no bug queue. They don't have a bug queue. When they introduce a bug, pipeline breaks, they have to fix it immediately. I see 0 branches. People don't branch. We never made it a mandate. We left it up to the team. So far, every single team that went commit to production without humans stopped branching. And of course, you need flexible feature flags for that. This is interesting. I find that teams code all the time. No more waiting for the build guy to stabilize the build. No more QA certification period. Everything is automated, so they either code tests or they code functionality, but they're coding 100% of the time. So what's next for us? We're still converting legacy, right? So we haven't converted all of our systems, so we're still doing that. Our tool set is still not as good as we want it to be. It's not as user-friendly. It works, but it's not very user-friendly, and sometimes it's outdated, so we need to upgrade our tool set. UI testing. This industry hasn't cracked that nut yet, so we want to spend a lot of time working with the latest technologies in UI testing space. And finally, technical excellence. With CD, I know that the code works and does what I expect it to do. But I don't know that this code is maintainable or that it's extensible or that it's readable. So I want to spend a lot of my time looking at this problem. So I think we're out of time. Thank you very much.